Okay, I've already done a previous recording or recordings explaining every single question on this practice test, right? I'm just going to do a quick review, jump around. Now, the very first one, the square root of negative 16, what's the answer to that?
4i.
4i. Now, let's just take a moment to talk about this, right? What is the square root of 16?
4.
Why is that?
Because 4 times 4 equals 16.
Because 4 times 4 equals 16, right? So when we say the square root of negative 16, there is no number that you could multiply with itself that'll give you a negative. Because 4 times 4 is 16, and even negative 4 times negative 4 is not negative 16, it's positive 16. That's why imaginary values come out, okay? So you cannot do the square root of a negative. I mean, you could, you get imaginary. But you can do the cube root of negative numbers. You can do the cube root of negative numbers. So if I say, what is the cube root of negative 27? What would that answer be?
3.
Is it 3? Is 3 times 3 times 3 27? I mean negative 27?
Yes, because 3 times 3 is
3i?
It's 3i.
It's not 3i. It's actually negative 3. Negative 3 is your answer. Okay? So why is that? Because when I say third root, I'm asking what value times itself 3 times will give you the inside number. So what is negative 3 times negative 3, that's positive 9, times negative 3, it'll get you that negative 27. So ladies and gentlemen, you can do the cube root of a negative. You cannot do the square root of a negative. You end up with imaginary on square roots. So on the test, it's going to be almost identical to this practice test. Some questions will be identical, but for the most part, you could just, this was a negative 16, maybe on tomorrow's test it's going to be a negative 25. What's the square root of negative 25?
5.
5i. What's the square root of a negative 9?
Negative
3i.
That's right.
Okay. What's the square root of negative 4?
Negative
2i. Right? Okay, so whenever you have a negative in there, you're just going to slap on an I when it's a square root. But when it's a cube root, you actually get a negative answer. Like, let's take a look at number 9. Number 9 is a negative 27 inside a cube root. Okay, and let me start by saying this. On all of these simplifying questions, the first half of the test, the hardest part of the test, on every single one of these, you need to split the root. So your one problem actually becomes 2 simpler problems. Split the root. So the very first step on showing your work on any simplification problem of roots is that you split the root. Okay? So your one problem becomes 2 easier problems, right? Now, what is the cube root of negative 27?
Negative 3.
It's just negative 3, right?
That's right.
No I, right? It's just negative 3. Okay? Now, how about the cube root of x to the third power?
X to the
That's just x, right? The cube root and the cube eliminate themselves. Or another way of thinking about it is that a cube root is really the power of 1/3, which is kind of like dividing this inside power by 3. So 3 divided by 3 is 1, so x to the 1, but there's no need to put the 1 right there. Really easy stuff, guys. So on every single one of these questions simplifying radicals, you need to break up that original radical into a bunch of easier, smaller radicals. Okay? So like, pick one. Which one do you want to see?
Number 10.
Number 10?
Or actually number 11. No.
11?
Yeah.
Okay, let's do number 11. Oh, we'll do a couple if you want. But anyway, okay, on this one, we need to remember, and I always forget for some reason, this negative 3, I need to multiply it by my answer once I have it. Okay? So I'm just going to put an arrow just to remind myself that I need to multiply my answer by negative 3. So step 1 on simplifying any radical is what? Come on, guys. On your paper, your work, what's the first step you need to show? Separating them. Splitting them up. So let's split up that third root. You're going to put the third root of 256. You're going to put the third root of x, and you're going to put the third root of y to the 9th. That's the first step on every single one of your work. When you're doing the simplifying roots, split them up. So your one problem becomes 3 problems, right? So let's think about the cube root of 256. Because it's cube root, you want a perfect cube number. If it were a square root, you want a perfect square number, but cube root, you want a perfect cube number. So let's think of perfect cube numbers. What are they?
1, 8, 27.
Okay, 1, and we're not even going to use it. 8, because 2 times 2 times 2 is 8. What's the next one? 27, because 3 times 3 is 9 times 3 is 27. The next one?
64.
64, because 4 times 4 times 4 is 64. The next one, 5 times 5 is 25. 125. And 216, 6 times 6 times 6. But you know what? That's already too big, because I already know that not even 125 will give me 256. If I multiply it by 2, that'll be 250, not 256. So it's going to be one of these three numbers. Now, the strategy for this is on your calculator, which everybody should have a calculator. Go ahead and do 256 divided by one of these. Try 8. If it doesn't work, try 27 or 64. 64 works? Okay, 64. If I do 256 divided by 64, what is it? So you could rewrite 256 as 64 times 4. Again, the trick is to simply use your calculator. 256 divided by one of these three numbers, see if it works, and it works, 64. 256 divided by 64, that was 4, so I rewrite it as 64 times 4. Now, when I split the third root, I could actually do the third root of 64. What's the third root of 64?
4.
So you have a nice, beautiful 4. The cube root of 4 is going to stay right there. What about the cube root of x? Could I even do that? No, you can't. Because you think about it, the cube root's really the power of 1/3. It's kind of like dividing this power by 3, but it's the power of 1. You can't divide it by 3. So you're just going to leave it. And how about that last one? This last one right here. Could he do this?
Yeah.
Heck yeah.
Y to 3.
Y to the third. Remember, cube root is kind of like dividing the inside power by 3. After all, the cube root's the power of 1/3. So that's like saying 9 divided by 3, which is 3. So we get a nice, beautiful y to the third. Guys, this is almost our answer. I once again almost forgot about that -3 out there. Let's bring it down, that -3, and put it right in front of the 4 and multiply it. Don't forget that on the test, please. Now, all we need to do to this answer is simplify it, rearrange it. Okay? So what is -3 times 4? -12. And then how about, what else is nice that I could write right next to the -12? Y to the third. And then at the very end, we put our radical, our cube root of what?
4x.
4 and x together. And that's it. There's your answer. -12 y to the third cube root of 4x. So again, step 1 on all of these guys is to take your original radical and split it up to a bunch of smaller radicals that are easier to work with. Okay? Which other one would you guys like to see?
14.
14?
Or are we only doing the top section?
We're doing anything you want. This is just another review. By the way, there's a review explaining every single question that's already posted. So you want to do 14, the one with the fifth root? Let's do it. Now, what's the first step on any simplification of roots? Splitting them up, separating them. So let's do that. The fifth root of 32. The fifth root of x to the 20th. The fifth root of y to the third. So I'm assuming you guys thought this was a hard question, right? Because you asked for it. But the fifth root of 32, what does a fifth root really mean?
2.
Yeah, it's asking you what number times itself 5 times will give you 32. So start with the smallest number. What's 2 times 2? 4 times 2. 8 times 2. 16 times 2 is 32. Right? 2 times 2 times 2 times 2 times 2. That is 32. So this answer is simply 2. Now, how about the fifth root of x to the 20th? Remember, the fifth root is kind of like the power of 1/5, which means that you're dividing this 20 by 5, which will give you x to the 4th. X to the 4th. Right? And how about that last one? Could I divide 3 by 5? No, so I just leave it. Right? I just leave it. Okay? So I'm going to leave it the fifth root of y to the third. And now, do I need to rearrange anything? No, it's beautiful. It's perfect. The 2, the x to the 4th, the fifth root of y to the third, that's your answer. It's an easy problem. Right? Which one? 15? 13. Sure, why not? 13, another one with that nasty -3 out there that we need to multiply by at the very end. So just put an arrow. That way you know that you need to multiply that -3 at the very end. All right, so step 1 to simplifying any radical. What's step 1 on the work you're going to show? Break it up, split it up. Okay, so we're going to have the third root of 162. We're going to have the third root of x to the 12th. We're going to have the third root of y to the 10th. Split it up. Everybody needs to show this work. Okay, now since we're dealing with third roots, let's do perfect cube numbers. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125, and that's already too big. So since I'm doing the third root of 162, I want a perfect cube number in there. So it's going to be one of these 3 numbers. And with your calculator, all you have to do is do 162 divided by 8. See if it works. Right? Or 162 divided by 27. Or 162 divided by 64. So guys, do it on the calculator. 27 works? Okay, so obviously if you try 8 doesn't work, try 64, and then this one does work. So we said that 162 divided by 27 is what?
6.
Okay, so we're going to rewrite 162, we're going to rewrite it as 27 times 6. That way, when we split the cube root, you could actually do the cube root of 27. What's the cube root of 27? 3. So this answer right here is just 3. And let's not forget about the outside -3 that I'm going to bring down here to multiply it by that 3 at the very end. But so far, I have the cube root of 6 that comes down. And now how about this guy? The cube root, what do I do with this 12?
Turns into a 4.
It turns into a 4. 12 divided by 3 is 4. So that's going to become x to the 4th, no more cube root. And how about this last one? I want this to be divisible by 3, right? It's not divisible by 3. 10 divided by 3 doesn't work. So what we're going to do is rewrite it so we could get something divisible by 3. So you're going to do y to the 9th times another y. That way, when you split the third root and the third root, you could do this first one, the third root of y to the 9th. That becomes simply y to the 3rd. 9 divided by 3 is 3. And the other one, you just bring it down. The third root of y to the 1, but you don't have to put to the 1. So guys, this is our answer. We just need to rewrite it nicely. How about the -3 times 3? That's -9. And then what else could I write right next to the -9? X to the 4th, y to the 3rd. And then at the very end, we put our radicals, the third root of 6 and y together underneath one root. This is it, guys. This is the answer. And you know what? This is like one of the hardest questions that there is on the test. Okay, now it's not enough for you guys to be sitting right now at your desk saying, "Oh, I understand this. I got this. I wrote it down on my practice test. I'm ready for it." Because you're not, right? You could understand what I'm doing. You could have written it down on your paper. The only way to become a master at this is what? Practice. Practice makes perfect. So what you should do tonight, like if you thought, "Oh, this one is kind of challenging," you put a little star right next to it, and then at night, copy it over on a separate sheet of paper, try to do it again. If you can't get to that answer, then get on Edmodo, get on my YouTube channel, watch the explanation until you're actually able to get it. You do it once, you do it twice, you do it 3 times, you do it as many times as you need to till it becomes easy. Oh wait, I'm recording. I shouldn't be recording. Okay, so the first half of the test, it's all about taking your root and splitting them up, making them easier, right? You know what, before we move on to the other sections, let me do a couple more here. Like, bless you, number 7, you're going to have to split that up. But it's a fraction, so you're going to split it on top, and you're going to split it on the bottom. And that becomes like 2 problems to do. Like down here, when we did these guys, this one problem became 1, 2, 3 problems. But up here, you split it, it becomes 2 problems. Now, could you do the square root of q? No. Could you do the square root of 32?
Yes.
Yes. Okay, so let's do this on the side. The square root of 32, you're going to rewrite it as what? 4 times 8?
16 times
16 times 2 is better. 16 times 2, the highest perfect square number possible. That way you rewrite it as 4 square root of 2. So far, I want to write it down here, actually over here. The square root of q is up on top, and 4 square root of 2 is on the bottom. And a lot of people are going to write that answer and only get half credit because you cannot leave a radical in the denominator. You can't leave a square root in the denominator. So let's get rid of that square root by multiplying both top and bottom by the square root of 2. Okay? Because when you multiply a square root value with itself, it undoes the square root and you just have the value left over. So up on top, I could actually do the square root times the square root of something with something else. That'll be both of them together, 2q underneath 1 square root. The bottom, I'm really going to have 4 times 2. Because the square root of 2 times square root of 2, that's just 2. So when you go 4 times 2, you're going to get 8 on the bottom. And ladies and gentlemen, now that's your answer right there, the square root of 2q over 8. Cool? I might as well explain this next one right here. You could split it right from the start, which on the other video I did. I split it right from the start, and I ended up simplifying everything possible. Or you could look at what's on the inside and try to simplify that fraction first. Okay, so if you could simplify, you might as well do so. What do I mean by that? There's a b up on top that you could cancel with the b on the bottom. That'll make it easier. There's also one a up on top that'll cancel with one of these, and you're going to have 5 left over on the bottom. So we could rewrite this problem as the square root of 25 over 16 a to the 5th. And then you could split the root and say the square root of 25, which that's an easy answer, and then the square root of 16 a to the 5th. So it's like doing 2 smaller problems easier, which you're going to end up with a 5 up on top. And on the bottom, when I do the square root of 16 and the square root of a to the 5th, well, I know that the square root of 16 is pretty easy. That's just the answer 4. But the square root of a to the 5th, square root means that you're kind of dividing this power by 2. So 5 is not divisible by 2. So you want to rewrite it with multiplication. And what do we rewrite it as? A to the 4th times a to the 1. That way, when you split it, you'll get a to the 2nd and then square root of a. So this was the bottom simplified. So I'm going to rewrite it up here. It'll be 4a squared square root of a. Now, a lot of us, if you leave that as your answer, you're only going to get half credit. You need to get rid of what? The square root of a on the bottom. So I'm going to multiply both top and bottom by what? Just the square root of a. So up on top, I do get 5 square root of a. On the bottom, you do get the square root of a times square root of a. That's just going to be a. So check this out. I want to circle it and put an a right here. No more square root. So what's 4a squared times a? 4a to the 3rd. A to the 2nd times a is a to the 3rd. So, ladies and gentlemen, this is your answer right here. 5 square root of a over 4a to the 3rd. Now, this whole top part is about splitting it and dealing with each one, each smaller, easier question. The next 4 questions are super easy. All you're doing is rewriting from exponential form to radical form, or radical form to exponential form. So what does the power of 1/2 actually mean? The square root. Now let me ask you this. What has the power of 1/2? Only the x. All right? The 12 does not have the power of 1/2. So only the x belongs inside the square root. This is the only thing that has a square root. So just rewrite it. 12 out in front, square root of x. Done. Do not make the mistake of putting the 12 in here. That would be incorrect. Because if the 12 belonged in there, then it should have had parentheses including it. But it doesn't have parentheses including it, so it's not included in here. It's out here. Compared to this next one, you want to change this radical to the power of 1/2? Take that entire 20x. The entire 20x is inside the square root. So the entire 20x is going to have the power of 1/2. It's that easy, guys. The rest of this test is cake. On this one, all you need to remember is that it's a power over a root. And let me say this, guys. You already know, like if you had the third root of x to the ninth, what do you do right here, guys? What do you do right here?
You multiply the 9 by a half.
9 divided by 3, right? Now, you know,
I don't
the third is really the third root's really the 1/3 power. So it's kind of like dividing 9 by 3, right? So it's kind of like doing this, x to the 9 divided by 3. And notice what went up on top, the power. What went on the bottom, the root. That's what you need to know, that the top one is the power and the bottom one's the root. Okay? So what am I going to write as my radical? What is the root? What is the root? 4. What's the power? 3. Done. Okay, let me throw in a couple extra ones. How about this one? X to the 7/8. What am I going to write that as? 8th root, 7 inside. X to the 7th. Perfect. All right, how about another one? Let's just do let's do x to the 2/3. What do you get?
3x to x to the second.
The third root of x to the 2nd. Perfect. That's an easy point, guys. All of these are actually easy. Why am I explaining all of them? I don't know. Did we need to explain all of them?
Yeah.
Or how about you guys just ask me? Did anybody want to see 19?
Well,
This one, just the whole thing to the 1/5 power. 25x to the 3rd to the 1/5 power. You don't have to do anything else.
Well, why parentheses?
Why parentheses? Because notice that all of this is inside the 5th root, right? So if you didn't put parentheses, then the 1/5, the 5th root would only belong to the x. It wouldn't belong to the 25. So the whole thing's inside parentheses because the 25, the whole thing's inside of the 5th root. All right, which other one?
15.
15? You guys want to go back and do 15?
no.
We can do that if you want. It's your time. It's the same thing. All you're going to do is split it up into the 6th root, right? So, all right, let's just go through it. 6th root of 256, the 6th root of x to the 18th, the 6th root of y to the 12th, the 6th root of z to the 5th. So 6th root, if you think about what that means, is you want a number times itself 6 times. So ladies and gentlemen, let's start with the easiest number, not 1, but 2. What is 2? Let's do this together. What's 2 times 2? 4 times 2? 8 times 2? 16 times 2? 32 times 2? 64, right? Now, it would have been nice if this was a 64, but it's not. Now, if you try the next one, 3 times 3 times 3 times 3 times 3, it's going to be way too big for 256. So you're going to have to use this first one, 64. So try to do that with the calculator. 256 divided by 64. So on a calculator, 256 divided by 64 gave us the answer 4, which means we could rewrite it as 64 times 4. And you're going to split that 6th root to each of them. And the 6th root of 64 we know is what? 2. Because 2 times, right up here, it says 2 times 2, 6 times gives 64. So the 6th root of 64 is 2. The 6th root of 4, you can't do it, bring it down. Could we do the 6th root of 18? Yeah. Heck yeah, that's like saying 18 divided by 6. Remember, power over root. 18 divided by 6. So what do we get?
3.
X to the 3rd. And how about this one? 12 over 6. Power over root. What do we get? Y to the 2nd. And the last one, 5 over 6. We can't do it. 5 divided by 6 you can't do, so bring it down. The 6th root of z to the 5th. That's your answer. Just rearrange it. 2 out in front. Then we have the x to the 3rd, the y to the 2nd, and at the very end we put both radicals together underneath one radical, 4z to the 5th. That's your answer, guys, right there. That's as hard as it gets. It's as hard as it gets.
Can we do number 12?
Number 12?
It's a long video already.
Yeah.
Alright.
It is a long video. All right. 2 times 2 times 2 is 8. 3 times 3 times 3, 27. 4 times 4 times 4, 64. And 125 is already too big. So with your calculator, do 135
7 times 5.
divided by one of those guys. Right? Oh yeah, step 1 is to do this. Split it up. Okay, so when you divide by 27, it gives you 5, right? So 27 times 5 works. That way when you split that third root, the third root of 27 is 3, and the third root of 5, you're just going to bring it down, the third root of 5. And the third root of x to the 7th. You want something divisible by 3. Remember power over root? But we need to rewrite this as x to the 6th because 7 is not divisible by 3. So x to the 6th times x to the 1. That way when you split that third root, you're going to have x squared and bring down the cube root of x to the 1. That's your answer. All you need to do is rewrite it. So your final answer will be the 3, the x to the 2nd, and then square root or the cube root of 5x together. That's your answer right there.
Does it matter if you put the 1 on the x?
It doesn't matter if you put the 1 on the x, but it's not necessary. And this last part of the test is the easiest, right? All you have to do is change that 729 to become 3 to a certain power. 3 to a certain power. And you figure that out with your calculator. That way you could set it up as a new equation that reads x minus 4 equals that answer you get right there and scratch out the 3's. Oh man, I don't even think I'm going to upload this to Edmodo. It'll be on my YouTube channel.